Welcome to watch this video. In this video, we're going to explain about the Let 1 of COA. So my name is Yuling. I'm going to explain about the part B, and then my groupmate is Pavani Katria. She will explain about part C. So in the program in part B, we will perform addition and subtraction operation on 32-bit unsigned integer. So we have included the Irvin 32, and then in the dot data we have four variable. They are all D word, which is 4 bytes, and then we have while1, which holds the value of 10,000 hexa, while2 holds the value of 40,000 hexa, and while3 holds 20,000 hexa. And also we'll perform the operation and store the final value at the variable final val. And we have the dot code. So in this, these are all the line will be executed to perform the operations. So now allow me to build and compile. And then, so before I debug, I should add a breakpoint here. Okay, so now I will debug and step over. Okay, now I will get all the windows. So the first window we have here is watch one. So this will show all the variable we have in this program, and auto will show the updates to these variables, and the register. So for the register, we will use only the register EAX. So we have to focus on this only. And for the memory, we'll show the memory address of the variable. So let's say if I pick the address of while1, so this will show 10,000 hexa, which is the same here. And let's say if I show while2, this will give 40,000 hexa. The same if I want to show while3, I will have 20,000 hexa, which is here. And then we also have the disassembly window. So now I'll press F10. So when this one, we can see the value in while1. So when I press again, I should move the value in while1 into EAX. So now I press F10. So yeah, now my value in EAX has become the same as that in while1, which is 10,000 hexa. And then moving on to the next line, we will add the value in while2 to EAX, which is 40,000. We add 10,000 hexa. So F10 again. So at this point, my value in EAX is 50,000 hexa. And you can see here the value here is the sum of while1 and while2 in decimal. And moving on to line 22, we will subtract the value in while3, which is 20,000, from that value now in EAX, which is 50,000. So F10 again. So now my value in EAX has become 30,000 hexa, and then, oops, I pressed twice. So I have already execute line 23. So I have moved the final value from EAX into final val. So I can see here the value in final val now is the same as that in EAX. Let's check here. Final val. Yes, is now 30,000, same as that in EAX. And if I press F10 again, I should call the down regs, which should display all the registers and this value in the terminal. Let's check. Okay, so inside this we have EAX, which is equal to 30,000 hexa. And then let us check the disassembly. So in this one, so this is our source code in white color, and in the gray one, this should be what actually happen with this source code. So if I press F10 again, I should exit the program. Yeah. So that's all for part B of that one, and we will continue with part C.
Good day to Dr. Fawad. My name is Pavani from section 01, and today I'll be presenting our lab 1 presentation. And my presentation will be on lab 1C, the solution on lab 1C. So the lab 1C is a program that adds and subtracts 8 and 16-bit unsigned integers and stores the sum in a variable. So first, we'll take a look at the assembly code. There's an include directive to include the Arwen32 library. There's a .data directive, which shows that we have 4 word size variables and 4 byte size variables. We have the .code directive, and below this is all the code that will be executed when the program runs. So I'll go ahead and build, compile, debug, build that one, see? And then because I've attached a breakpoint, under main prop. So I'll just step over. And this will show all the windows we need for debugging. So we have this assembly window here. We have the watch, autos, registers, and the memory. Which first I will initialize to and value. Okay. Now, I also have inputted all the variables that we're going to watch. So all the variables from val w1 to final val w and val w1 to final val v. And the autos will track the variables automatically, whichever one updates. And we also have the registers screen, which shows all the registers and the current values inside them. So the register that we'll be most interested in is the EAX register, extended EAX register. This is the AX register, and this is the AH register, which are the ones that we'll be most interested in. Okay, so when I press F10, a cursor will show up here, which shows that this line will be executed next. And this first line, what it does is that it moves the value of inside val w1 into AX. So the value inside val w1 is 1000 hexa. And when I press F, and this value will be moved into the AX register. So this would display here, and this would display, this will not display here, but the value 4096 in hexa will be stored inside this register. So as you can see, 1000 has been stored inside the AX register, and 1000 is 4096 in decimal. So the X register in the autos has also shows. So see, val w1 and AX is the same because val w1 has been moved into AX. And then we move to the second line, which is the value inside val w2 will be added to AX. So the value inside val w2 is 4000H. It will be added to the AX register, and then it updates correspondingly here and here. And then the value inside val w3 will now be subtracted from the AX register. So 2000 hexa subtracted from 5000 hexa. And see here, it updates here also, and also here. And finally, we will move the final value inside the AX register, this 3000 hexa, into a final val w. So here, the values here and here will change to reflect the value inside the AX register currently. So this 12288 value should be moved here when I press F10 next. And as you can see, it's the same value. So the operation was done successfully, and then we will call dump regs. And this displays all the registers, just like the register screen. And as you the final value has already been successfully stored inside AX. And then now we move to the second part of the program where we will be adding and subtracting the bite-sized variables. So same thing, we will move, first I'm going to change the memory here to val v1. And yeah, this just shows that val v1 is at the memory address 0x001b6008. Just now, val w1 was at 0x001b6000. So Okay. Well, so currently it has a value of 10, which is correct. It does have 10 hexa. And I'm gonna move val B1 inside AH. Val B1, okay. Val B1 has a hexa value of 10 or a decimal value of 16, and this will be moved into the AH register, and this will be updated correspondingly here. Okay, and then now 40 hexa will be added to AH. So the value inside val B2, 40 hexa will be added into the AH register, and it will be updated here and here. So now it turns into 50 and 80 in decimal. And then we'll be subtracting the value inside val B3 from the AH register. So 20 hexa will be subtracted. So turn into 30 or 48 in decimal. And finally, we'll move the value inside the AH register currently into the final val B variable. So here, and here, and here, it should update accordingly to reflect the value inside AH. And as you can see, final val B has successfully stored the value currently inside the H register, which is 30 hexa or 48 decimal. And then we can call numRegs, and it will show the register. So 30. Okay. And then just take a look at the disassembly code for a bit. We started here at this breakpoint, and this is the address, and this is the source code, and yes, so this is what the disassembly code looks like for this program. And when I press F10 again, it will exit. Okay. All right, that's it for the presentation. Thank you.